In the previous video, we looked at how to solve first order linear differential equations. In this video, we're actually just going to follow through and do two examples of this. So just a reminder that we have a first order linear differential equation up there, a1 of t x prime plus a naught of t x equal to g of t. So if we have something like that, some differential equation like that, what we first do is we put it into standard form. So as a reminder, that means we divide by a1 of t. And then once we do that, on at each side of this equation, we get x prime plus p of tx is equal to q of t, where p of t was just a naught divided by a sub 1, and q of t is just g of t divided by a1 of t. Once we do all of that, we then multiply by something we call the integrating factor. And what was that integrating factor? That was e raised to the integral of p of t dt. If we multiply by that everywhere, then multiply both the sides of that standard form by that integrating factor, we get the derivative of the product mu of t times x is equal to mu of t times q of t. Right? Because that left-hand side will always end up being the derivative of that product, mu of t times x. And then after we are done with that, we just integrate both sides. So we integrate the left-hand side, that's mu of t times x. And we integrate the right-hand side using any of the techniques, any of the appropriate techniques that we've learned in previous courses. And so we will get mu of t times x is equal to the integral of mu of t times q of t. Then we can just divide by mu of t on both sides to solve for x. And that will be our solution method for these problems. So let's do that with a couple of examples. So we have this equation dx dt is equal to 3x. We want to write this into standard form. This is dx dt minus 3x is equal to 0, right? We just subtracted 3x over to the other side, and this is our standard form. If we write it out like that, what we notice is that p of t is equal to negative 3. And we want to find our integrating factor. Well, first we need to integrate p of t with respect to t. And we do this integral of negative 3 dt, and this is equal to negative 3t. And then we technically have plus c here, right? Anytime we integrate this, we need to add some constant term out at the end, but we actually get to ignore that in these problems, or at least at this point we do, because we're trying to find an integrating factor here. We just need an integrating factor. So we just need some function that we multiply by that will help us turn the left-hand side into that product. Well, since we only need one function to do that, we can actually choose c to be anything. So to make everything simpler, we always just pick c equal to 0. So we get to ignore that plus c in this particular part of the problem. So what do we get here? This tells us mu of t, our integrating factor, is e raised to that integral of p of t dt, which we just found was negative 3t. So our integrating factor for this problem is going to be e raised to the negative 3t. Now, what do we do with that? Well, let's zoom in a little bit more just to give us some more space here. So what do we do with all of that? Well, we multiply both sides of the standard form by the integrating factor. So this becomes e to the negative 3t times dx dt. and minus 3e to the negative 3t x is equal to 0. And we have to multiply this term by e to the negative 3t as well. But that's 0 times e to the negative 3t, so that's just 0. Then notice this left-hand side is, in fact, the derivative of e to the negative 3t times x. Remember, x is a function of t. So if we take that derivative using the product rule, we, in fact, get the first e to the negative 3t times the derivative of the second minus the derivative of the first, plus the derivative of the first times the second, which is just x. So in fact, we get what we needed here. So this goes to show that we really didn't need that plus c there. We just needed some function that will do this, will turn this into the product, or the derivative of the product. So we get this. Well, now that we have that, we integrate both sides. We integrate the left side. Well, that's just always going to be the product that's on the inside here. So that is e to the negative 3t times x. And then we integrate the right-hand side. So we integrate 0 with respect to t. Well, that is just c, some constant. And here that c is important now, so we need to leave that. So we, in fact, get e to the negative 3t times x is equal to c. So to actually solve for x, we just divide both sides by e to the negative 3t. If we divide by e to the negative 3t, that's the same as multiplying by e to the positive 3t. So x is equal to c e to the 3t. And we are done. All right. So let's go ahead and move on down. Oops. And do another example. And we see that we have the answer written here, e to the negative 3tx is equal to c. So we just wrote out the answer before we divided through. I would prefer you to go ahead and divide through and write x is equal to c divided by e to the negative 3t, which is the same as c e to the positive 3t. Okay, so we're going to do that same thing again for one more example here. And so we already have everything written in standard. No, we don't. We don't have everything written in standard form. I'm sorry. I'm being a little slow and dumb. All right. So here we want to write into standard form. To do that, we need to divide by t on every term. So we get dx dt minus 4 over t times x is equal to t to the 5th e to the t. So that's standard form. Once we do this, our integrating factor mu of t is going to be e raised to the integral of p of t dt. So this means we want the integral of negative 4 over t dt. Well, this is negative 4 integral of 1 over t dt. And so we get negative 4 ln of the absolute value of t plus c, but again, we don't really need the plus c part. So we get negative 4 ln of absolute value of t. And so our integrating factor is going to be e raised to the negative 4 ln of the absolute value of t, except we just need some positive function here. So we get, let's see, e to the ln of the absolute value of t, all raised to the negative 4. E to the ln of t is just t. So this is t to the negative 4th. So that's what our integrating factor is going to be here. All right. So we want to clear all of that again, and we're going to then multiply everything by t to the negative fourth. Well, when we do that, the left-hand side is always going to be the derivative of the integrating factor, which is t to the negative fourth times x. And the right-hand side is going to be, that was t to the fifth e to the t earlier, but now we have multiplied by t to the negative fourth. So remember, once we had it in standard form, this is now t to the fifth e to the t. And now we're going to multiply by our integrating factor, which was t to the negative fourth. Well, this is now t e to the t. Okay. So we have the derivative of this product, t to the negative fourth times x, is equal to t e to the t. So we need to integrate both sides. That means we need to integrate t e to the t with respect to t. Well, to do this, we need to do our integration by parts method. So we have u is equal to t, which will give us du is equal to dt. And then we're going to take dv is equal to e to the t dt, or v is e to the t. So integration by parts says that this is equal to uv minus the integral of v du. All right, so this was equal to t e to the t minus the integral of e to the t dt, which is t e to the t minus e to the t plus some constant c. So we get t e to the t minus e to the t plus some constant c. And now that we've integrated both sides, the left-hand side was t to the negative fourth times x is equal to t e to the t minus e to the t plus c. Multiply by t to the fourth everywhere, and we get x is equal to t to the fifth e to the t minus t to the fourth e to the t plus c t to the fourth. And this will be our equation x. So we have solved our differential equation. That'll be the end of this video. We'll do a couple more examples in the next video.